Hello viewers and welcome back to for final maths class. Today we are going to look at differentiation of function of a function, aka the chain rule, or also known as the chain rule. Okay, now when you have a function y which is in u, okay, and then u is also a function in x, all right, so you have a function y with respect to u, and also u is also in a function of x. We term that particular function as what? Function of a function. So with those kind of functions, what we use to resolve them is the chain rule, okay? And the chain rule also says that dy dx is equal to dy du times du dx. Okay, so if you have a function of a function, this is the formula that we use it to differentiate that particular function of a function. So an example is if you have a function like x plus 5 to the power say 6, this particular function will be difficult for you to differentiate. Why? Because it will lead you to tedious multiplications. Okay, so before you will be able to differentiate this particular function, you will have to multiply it by itself 6 times, all right, and expand the bracket 6 different times. So you can imagine how tedious this particular function would be, all right. So when we are dealing with a function which is of this nature, we use the chain rule to differentiate, to find the derivative of that. So they'll differentiate it like x to the power n. If you could remember, when we were doing the rules of differentiation, we dealt with a certain rule which is like this. So if you have y to be equal to x to the power n, we use that particular rule. The one that we use to differentiate this particular function is what we use to differentiate the function of a function, which is what? You find the dy dx of this will be x to the power, so this n will come and multiply the x, which is this, then we subtract 1 from the n, all right. So with the chain rule too, what we do is you will first of all multiply the power by the, so if you have y to be equal to ax plus b to the power n, okay, what we do is the dy dx, or the differential coefficient of this, will be equal to the n will come down to multiply this, all right, which is what you will differentiate this times the derivative of the one in the bracket. Okay, so you differentiate all of this times the derivative of the one in the bracket, so it will be n times the bracket, then you subtract 1 from the bracket times the derivative of the bracket itself, which is what? Ax plus b. Okay, so this is how it will be done, all right. So when you have a function of a function, anything of this nature, this is how we differentiate it. So let's see how we will be able to differentiate this particular example that I've given on the board before we look at more examples. Okay, so using this particular rule over there, or using this particular approach that we just used to expand or to differentiate this particular function, this is what we do. Since it is equal to, you have dy dx to be equal to, first of all, you will have to name, okay, before we did it with dy dx, let me use this particular formula to solve it for us all to see the way forward. Okay, so first you will let u to be equal to the brackets, which is what? X plus 5, all right. So having let u, then you differentiate the u now will become what? Du dx, since it is in the function of what? X. Okay, so it will be du dx to be equal to what? 1, all right. So now following this approach, first of all, you will have it in this way. Since you've made u to be equal to this, now the function will turn into y is equal to u to the power 6. Okay, now differentiating this, you have dy du to be equal to 6 u to the power 5. All right, now after doing that, then you substitute the values. All right, now we have dy du here, which is this, and then we have y to be this, and we have u to be here, and then we have du dy here. Okay, du dx here, so du dx is where? There. All right, so using the formula, we have dy dx to be equal to, we have dy du here. Where is dy du? We have dy du here, which is 6u to the power 5 times du dx. Du dx is what? Du dx is 1, so times 1. So over there our solution will be dy dx to be equal to 6u to the power what? 5. All right. So now from there, then you substitute the value of u back into the expression that you have here, which is what? U is equal to, so you have 6 into bracket u, which is x plus 5 to the power 5. Now when you differentiate this, this is how you will be having it using what? The chain rule. So what did we do? You have a function of a function. So first of all, you let u to be equal to the bracket itself. Okay, so u is equal to this. Then you differentiate u. After differentiating u, you have 1. Then we know that y is equal to what? U to the power 6. Then we differentiate this y to the power u to the power 6. So after differentiating it, you obtain 6 times u to the power 5. Then you substitute this particular things that you have done here into the formula that we just derived at or arrived at. So when you do that, this is what you'll be obtaining. Then you substitute the u. Since you let u to be equal to the bracket, which is x plus 5, you substitute it back into the formula. Let's look at one more example. Now we have the second example on the board, which is the function y is equal to 2x plus 5 to the power 5. Okay, so 2x plus 4 to the power 5. So what you do first is to let u to be equal to the members in the bracket, which is this. Then we differentiate u. So when you differentiate u, you have the u dx to be equal to 2. Okay, so the u dx to be equal to 2. Now we have the function to be y is equal to u to the power 5. Then you differentiate y again. So we have the y du to be equal, since it is in u, all right, with respect to u, so it will be the y du to be equal to 5u to the power 4. Okay, so after differentiating it in this way, then you put these values into the formula, okay, which is dy dx will be equal to dy du. So we have dy du here, which is what? 5u to the power 4 times the u dx. So the u dx is equal to what? 2. So now we have our differential coefficient or the derivative to be 10u to the power 4. So having done that, then you substitute the u value into the expression, back into the expression. So we have 10 into bracket u. U is equal to 2x plus 4 into to the power 4 here. So this will be the short solution for this particular example. Now we will tackle one more example, then we'll call it a day. Now we have another question on the board which says that y is equal to 3x to the power 3 minus 5, all in bracket to the power 6. Okay, just like we did with the previous questions. First of all, what you need to do is to let u to be equal to the one in the bracket, which is 3x to the power 3 minus 5. Then having done that, then we differentiate u with respect to x. So it will be du with respect to s dx, which is equal to a 3. We can multiply 3, so we will have 9x to the power 2. All right, so now our expression then becomes y is equal to u to the power 6. All right, so if it is u to the power 6, then we differentiate the expression, so you will get it dy du. So because it is with respect to u, so it will be dy du to be equal to what? 6u to the power 5. Okay, so having done all of this, then we substitute the values that we have into the formula. Okay, so now we have dy dx to be equal to dy du. Dy du is equal to 6u to the power 5 times du dx. So du dx is what? 9x squared. Okay, now we have dy dx to be equal to 9 times 6, we have 54 u to the power 5 x squared. Okay, so now having done that, then we substitute the value of u back into the expression, which will be what? 54 to the power 3x to the power 3 minus 5 to the power 5 times x to the power 2. All right, and this will give us the answer for the question on the board. Okay, so now look at the formula very well. When you look at it very, you realize that in the normal sense, okay, if we should cancel this and that, you have dy dx, which is this. Okay, so it is just, you know, a simple way. You understand that if this du cancel this du, you have what? Dy dx, which will give you the final answer. Okay, so what did we do? First of all, when you have the question, you just let u to be equal to the expression in the bracket, then you differentiate u, you have du dx, which is this. After that, then you rewrite the expression, which is y is equal to what? Us, since you made u to be equal to the y in the bracket, so it will be u to the power 6. All right, so if it is u to the power 6, then you differentiate the y, you have it with respect to u, which will be 6u to the power 5. So having done that, then you come and substitute all the values or all the expressions that you came out with from here into the formula, which is dy du times du dx. Okay, so after doing that, we have dy du to be 6u to the power 5 times du dx, which is 9x squared. You put them here. So after that, then you do your simple arithmetic, and then you arrive at your final answer. So this will be the end of differentiation of function of a function, aka the chain rule. Don't forget to subscribe if you haven't. Leave your comments, like and share for the benefit of others. Have a nice day.